To calculate the motor load, panel board, and transformer sizing, we will follow a step-by-step approach. Firstly, calculate the total motor load. The motor power per motor is 0.75 horsepower. The motor voltage is 120 volts. The motor current is 8.4 amps. The total motor load in amperage is the number of motors multiplied by the motor current. In this case, it's 15 multiplied by 8.4 amps, resulting in 126 amps. Secondly, calculate the panel board load. The total motor load is 126 amps. The panel board voltage is 120 volts. The panel board load in kilovolt amps is the total motor load in amps multiplied by the panel board voltage in volts, divided by 1000. Therefore, it is 126 amps multiplied by 120 volts, divided by 1000, resulting in 15.12 kilovolt amps. Thirdly, calculate the transformer load. The panel board load is 15.12 kilovolt amps. The power factor, which is estimated for motors, is 0.8. The transformer load in kilovolt amps is the panel board load in kilovolt amps, divided by the power factor. Thus, it is 15.12 kilovolt amps divided by 0.8, resulting in 18.9 kilovolt amps. Based on these calculations, you would need a panel board with a capacity of at least 15.12 kilovolt amps and a transformer with a capacity of at least 18.9 kilovolt amps. Remember that these calculations are based on estimated values and do not include any additional loads that may be connected to the panel board. It is always recommended to consult with a qualified electrician for a more accurate assessment and to comply with local electrical codes and safety regulations. The amperage of the motors must be determined, either by nameplate rating or by using NEC Table 430.248. This table provides full load currents for single-phase alternating current motors. Once the amperage is determined, the total motor load must be determined. For non-continuous loads, you can simply add all the motor amperage together. For continuous loads, however, NEC Article 430.24 specifies to multiply the largest motor load by 1.25 or 125% and then add the remaining motor loads to the number. For calculating the panel board load, you will want to determine the voltage of the panel board. In this case, it is a 120/208 volt panel board, so the voltage will be 120 volts, as this is what the motors are rated to. To find the kilovolt amps of the panel board, multiply the total motor load in amps by the panel board voltage in volts, and divide that number by 1000. To size the transformer, you must take into account the power factor. Motors do not operate at a perfect power factor of 1. An estimated power factor for motors is 0.8. So you will need to divide the panel board load in kilovolt amps by the power factor, which will give you the required transformer size in kilovolt amps. It is important to note that these calculations do not include any additional loads that may be connected to the panel board. Additional loads would include lighting, receptacles, or any other equipment. To accurately size the panel board and transformer, you must take into account all loads. Always consult with a qualified electrician for accurate assessments and to comply with local electrical codes and safety regulations. Motors require specific overcurrent protection and conductor sizing according to NEC Article 430. Each motor's branch circuit must be protected by an overcurrent device, such as a circuit breaker or fuses. The size of the overcurrent device is determined by NEC tables and calculations based on the motor's full load current and type. Conductors supplying the motors must be sized to handle the motor's full load current, with adjustments for voltage drop and ambient temperature. The NEC provides specific guidelines for conductor sizing in motor circuits. The panel board must have sufficient capacity to accommodate all the motor branch circuits and any other loads connected to it. The panel board's ampacity rating must be greater than the sum of all the connected loads. The panel board short circuit current rating must also be adequate to withstand the available fault current at the installation location. The transformer must be sized to provide sufficient power to the panel board and all connected loads. The transformer's kilovolt amp rating must be greater than the total calculated load. The transformer's voltage rating must match the panel board's voltage. It is important to consider future load growth when sizing the panel board and transformer. It is recommended to add some extra capacity to accommodate future expansion. This will prevent the need for costly upgrades later on. Electrical codes and standards such as the NEC provide detailed requirements for motor installations. These codes cover topics such as overcurrent protection, conductor sizing, grounding, and disconnecting means. It is essential to comply with all applicable codes and standards to ensure a safe and reliable installation. A qualified electrician should perform all electrical work related to motor installations. Electricians have the knowledge and experience to properly size components, install wiring, and ensure compliance with codes. Improperly installed motor circuits can be dangerous and can lead to equipment damage or fire. When selecting a panel board, consider the number of circuits required and the available space. Panel boards come in various sizes and configurations. Choose a panel board that has enough space for all the required circuit breakers and wiring. When selecting a transformer, consider the voltage, kilovolt amp rating, and efficiency. Transformers are available in various types, such as dry type and liquid filled. Choose a transformer that is suitable for the application and environment. Grounding is an important safety aspect of motor installations. All motor circuits must be properly grounded to prevent electrical shock hazards. The grounding system must comply with NEC requirements. Disconnecting means must be provided for each motor circuit. The disconnecting means must be readily accessible and capable of interrupting the motor's full load current. This allows for safe maintenance and repair of the motor. Motor controllers are used to start, stop, and control motors. Motor controllers can provide features such as overload protection, undervoltage protection, and speed control. The type of motor controller required depends on the motor's size and application. Surge protection devices can protect motor circuits from voltage surges caused by lightning or other electrical disturbances. Surge protection devices should be installed at the panel board and at the motor controller. Power quality is an important consideration for motor installations. Poor power quality can lead to motor overheating, reduced efficiency, and premature failure. Power quality problems can be caused by harmonics, voltage sags, and voltage swells. Power factor correction capacitors can improve the power factor of motor circuits. Power factor correction capacitors reduce the amount of reactive power drawn from the electrical system, which improves efficiency and reduces energy costs. Energy-efficient motors can save energy and reduce operating costs. Energy-efficient motors have a higher efficiency rating than standard motors. Consider using energy-efficient motors for new installations or replacements. Regular maintenance is essential for motor circuits. Maintenance tasks include inspecting wiring, tightening connections, and testing overcurrent devices. Regular maintenance can prevent problems and extend the life of the motor. Troubleshooting motor circuits requires specialized knowledge and equipment. Common motor circuit problems include open circuits, short circuits, and ground faults. A qualified electrician can diagnose and repair motor circuit problems. Safety is paramount when working with electrical circuits. Always energize the circuit before working on it. Use appropriate personal protective equipment, such as gloves and safety glasses. Follow all safety procedures and guidelines. Consider the ambient temperature when sizing conductors. Higher ambient temperatures reduce the ampacity of conductors. Refer to NEC tables for ampacity correction factors. Consider the altitude when sizing motors. Higher altitudes reduce the motor's horsepower rating. Refer to motor manufacturer's specifications for altitude rating factors. Consider the motor's duty cycle when sizing conductors and overcurrent devices. Motors that operate continuously require larger conductors and overcurrent devices than motors that operate intermittently. Refer to NEC Article 430 for motor duty cycle requirements. Harmonics can be generated by motors and other nonlinear loads. Harmonics can cause overheating of transformers, conductors, and other equipment. Harmonic filters can be used to reduce harmonic distortion. Variable frequency drives can be used to control the speed of motors. Variable frequency drives can save energy and improve process control. Soft starters can be used to reduce the starting current of motors. Soft starters can prevent voltage dips and reduce stress on the electrical system. Consider the motor starting method when sizing conductors and overcurrent devices. Different starting methods have different starting current requirements. Refer to NEC Article 430 for motor starting requirements. Consider the motor's enclosure type when selecting a motor. Different enclosure types are suitable for different environments. Choose a motor enclosure that is appropriate for the application. Consider the motor's insulation class when selecting a motor. Different insulation classes have different temperature ratings. Choose a motor insulation class that is appropriate for the application. Consider the motor's service factor when selecting a motor. The service factor is a measure of the motor's ability to handle overload conditions. Choose a motor with a service factor that is appropriate for the application. Consider the motor's efficiency when selecting a motor. Higher efficiency motors save energy and reduce operating costs. Choose a motor with a high efficiency rating. Consider the motor's power factor when selecting a motor. High power factor motors reduce the amount of reactive power drawn from the electrical system. Choose a motor with a high power factor rating. Consider the motor's slip when selecting a motor. Slip is the difference between the motor's synchronous speed and its actual speed. Choose a motor with a slip that is appropriate for the application. Consider the motor's torque characteristics when selecting a motor. Torque is the force that the motor produces. Choose a motor with torque characteristics that are appropriate for the application. Consider the motor's speed characteristics when selecting a motor. Speed is the rate at which the motor rotates. Choose a motor with speed characteristics that are appropriate for the application. Consider the motor's frame size when selecting a motor. Frame size is a standardized dimension that defines the motor's physical size and mounting dimensions. Choose a motor with a frame size that is compatible with the application. The NEC provides specific requirements for motor control circuits. Motor control circuits must be protected by overcurrent devices and must have disconnecting means. The NEC also specifies requirements for motor control circuit wiring. Motor control panels are used to house motor control components such as motor starters, overload relays, and control transformers. Motor control panels must be properly sized and installed to ensure safe and reliable operation. Motor protection relays are used to protect motors from overloads, short circuits, and other faults. Motor protection relays can be programmed to trip the motor circuit breaker when a fault occurs. Motor testing equipment is used to test motors and motor circuits. Motor testing equipment can be used to measure voltage, current, resistance, and insulation resistance. Motor repair shops can repair motors that have been damaged or have failed. Motor repair shops have the equipment and expertise to diagnose and repair motor problems. Motor manufacturers provide technical information and support for their motors. Motor manufacturers can provide information on motor selection, installation, and maintenance. It's also important to consider the rating of the transformer. The transformer's kilovolt amp rating must be adjusted for the ambient temperature and altitude. Refer to the transformer manufacturer's specifications for rating factors. The overcurrent protection for the transformer must be sized according to NEC Article 450. The overcurrent protection must protect the transformer from overloads and short circuits. The grounding of the transformer must comply with NEC Article 250. The grounding system must provide a low impedance path for fault currents. The transformer must be installed in a location that is accessible for maintenance and repair. The transformer must be protected from physical damage. The transformer must be ventilated to prevent overheating. The transformer must be inspected regularly for signs of damage or wear. The transformer must be tested periodically to ensure that it is operating properly. The transformer must be replaced when it reaches the end of its service life. Remember to follow all applicable codes and standards, such as the National Electrical Code, when installing and maintaining motor circuits and transformers. These codes and standards provide detailed requirements for safe and reliable electrical installations. Always consult with a qualified electrician for assistance with motor circuit and transformer installations. A qualified electrician has the knowledge and experience to ensure that the installation is done correctly and safely. Always prioritize safety when working with electricity. Electricity can be dangerous and can cause serious injury or death. Take all necessary precautions to protect yourself from electrical shock.